Example 4 is having us verify, and I'm going to draw my line. I've got my identities right there for me when I'm ready to use them. We've got sine over tangent plus cosine over cotangent, and we want to prove that that's equal to sine and cosine, or sine plus cosine. So the first thing I notice is there's a lot going on the left side. I guess it's a good rule of thumb that maybe the left side is usually more complicated, but you don't have to work there. But I'm going to the left side. Now, the first thing I want to get rid of, if I can, is tangent, and I'm going to highlight the other one a different color, cotangent. I'm going to use my same strategy from previous questions of get everything into sine and cosine. So I see, cotangent is cosine over sine, and I know that tangent is sine over cosine. So the reason I'm going to these quotient identities versus the reciprocal identity is because I don't want any tangents or cotangents. I want all sine cosine. So that means I'm going to have sine theta over tangent is sine theta over cosine theta plus cosine theta, and where I'm going to put cotangent, it's cosine over sine theta. So I'm just going to highlight this because, again, I think it's helpful to kind of trick the eye a little bit. So this is kind of like cleaning your bedroom. It's going to look messier before it gets neater here. So what we have here then is a complex fraction. We have a fraction within a fraction. So what I'm going to do is I'm going to keep the top, and I'm going to put it over 1. I'm going to flip the bottom up, and I'm going to change it to multiplication. Keep the top, flip the bottom up, change it to multiplication. That's just division of fractions right there. If it helps, this is the green fraction that I was working with. Here's the red fraction that I was working with. So now that's great because algebra tells us now that sine is going to cancel and cosine is going to cancel. And what I have here is cosine theta plus sine theta, which is what I want this to be. Now notice that what I actually have here is sine plus cosine. Close enough. Those two things, just that change in commutative nature is perfectly acceptable. Okay, our last question. We want to verify that sine over 1 minus cosine is equal to 1 plus sine over cosine. So this question, it's equally complicated on left or right side, so it really makes no difference. Maybe we'll do the left side just to be different. So I'm going to move my box over there. So let's work with the right-hand side here. Now, the first thing I want to mention is we did talk an awful lot about how our Pythagorean identities can be rewritten. So for example, I know that sine squared theta is equal to 1 minus cosine squared. Now, you'll notice right here on the left side that there's a 1 minus cosine. So if sine squared equals 1 minus cosine squared, my question for you is, does sine equal 1 minus cosine? So in other words, can I just do like a giant square root? And the answer to that is no, those are not equal. Okay, so that's the first thing. But we can kind of manipulate this to turn into a Pythagorean identity. So here's what I'm going to do. I'm going to start, everything is sine and cosine, so that's not any different. I'm starting on the right-hand side, and what I'm going to do is multiply by the conjugate. Now, we did conjugates a while ago. Conjugates are simply binomials that have the same first and last, but a different middle piece. So it's 1 plus cosine and 1 minus cosine, so it's opposite signs. Now, I'm not actually going to multiply the bottom out. I'm going to keep the bottom exactly as it is. Sine theta, 1 minus cosine theta. But the top I'm going to FOIL. 1 times 1 is 1. 1 times negative cosine theta is negative cosine theta. 1 times cosine theta is positive cosine theta. And negative cosine theta times positive cosine theta is negative cosine squared theta. So I notice a couple things here. The first really nice thing is that my cosines cancel. So I'm left with 1 minus cosine squared on top. Now again, 1 minus cosine on the bottom and the 1 minus cosine squared, they're not going to cancel each other out. But I do like the fact that on the bottom here, we have something that we want on the bottom. So we're in the right direction here. Now the next thing I notice is 1 minus cosine squared. That does equal something. 1 minus cosine squared, well, that's sine squared. So what I have now is sine squared theta, sine theta times 1 minus cosine theta. So I can use my Pythagorean identity to take 1 minus cosine squared and turn it into a sine squared. Now I can use my algebra skills, and we know that if there's a sine on the bottom and there's a sine squared on top, I can cancel one of those signs out. So what I have now is sine theta over 1 minus cosine theta, which is the left-hand side. And now it's done.